So, yeah, I am Jonathan Dionne, and I'm with the Long Branch Neighbourhood Association, as you guys might have heard, and I'm also doing my master's at the University of Toronto in forest conservation. So this is my internship through that program. So today we are doing the Deciduous tree walk, and we will be looking at basically be looking at different leaf formations to help us identify trees and understand a little bit, and we'll learn a little bit about some of the trees as well as we go. Yeah, so there are a couple things that I like to do before we get into really identifying the tree, and I guess the first thing is to look at the leaves. So there's basically I break it down into two main categories of leaves, and then within those two main categories, there's again another subdivision, and that kind of breaks all the trees down into four main groups, and then we can look at more minor details to get more accurate with our identification. But the first thing I look at is if there is a simple or a compound leaf. So a simple leaf is, as we can see up top here, it's just off the stem. There's one leaf that comes off, and it just looks like your standard leaf right off this the stem here. Whereas a compound leaf, you have another kind of stem-like structure called the petiole that grows up here, and then off of that there are actually little leaflets that attach to the petiole. Then within these categories you can have palmate and pinnate formation. So this is the simple leaf. We could see at the top here the palmate formation, and that goes for the veining of the leaf. So if we look here, all the veins meet at one point, and they kind of form this palm formation. You can see them branching out of this one point. So that's palmate. And then pinnate, you have the veins branching at different locations. So we could see here that all these veins kind of come off this central area. And then the exact same pattern can be seen with the compound leaves. So we have the palmate formation again, where all the leaflets attach at one single point. And then we have the pinnate formation, where all the leaflets attach at different points. So those are a couple of the first features that we look at. Obviously, after that, we start looking at other things like the bark of the tree. Then we can get into more details as well, such as lobes. And then we would also look at the margin of the leaf, which is the edges of the leaf. So those would have different textures. They could be sharp or smooth, like wavy. They could be pointed. And then again, obviously, there are more and more details that you can get to get more and more accurate with your estimations. But these are the kind of general guidelines to get us started with some of the easier estimations. All right, so we'll stop at this tree here. I guess we could spread out a little bit because this is the same tree as well. So you can look at either of these examples. I will start with pulling a leaf off here. Any guesses on if this is, on what type of leaf this is? Palmate, yes. Simple palmate leaf. Yeah. Yeah, okay, so I guess I should have been more clear. For the veining, it's only the primary veins. So if you look at the back of the leaves, you can see these primary veins are a lot more prominent than the secondary veins that come off of it. So for the palmate figuration, it's just these primary veins that we're looking at. And then this is kind of an interesting one because it's actually missing or has a less prominent fifth lobe. So you have this top lobe and then these two side lobes. And then if you look really closely at the bottom here, you can kind of see there's like a fifth lobe that's really just missing from this tree. And that's really characteristic of this type of tree. Do we have any guesses of the kind it is before we get going? This is actually a red maple. So like I said, red maples kind of miss this fifth lobe that is typical in most maples, or it's less prominent than you would expect it to be. Another characteristic trait is the in between the lobes here, this point is actually pointed. and not rounded. If you look at it, a lot of other maple species, this point will be rounded instead of pointed. And then the third thing I like to look for red maples is these side parts here on this main lobe tend to be parallel to each other instead of having an inward curvature like other maple leaves would have. The thing with red maple is they are commonly planted, but when people order them, they get this nice bright green tree and they're expecting a red tree and they get kind of upset. They say, well, I ordered a red maple, not a green one. And the funny thing is actually a lot of trees are named after the buds that they produce and not the leaf color. So red maples actually produce bright red buds in the spring before the keys are produced, and that's where it gets its name. Red maple are very, they can adapt to many different environments. They can live in very mesic or hydric conditions, yeah. So that's why they're planted a lot. There's actually, as hardy as red maples are, there's actually hybrids between red and silver maples that are thought to be even more hardy, called the Freeman maple. As I said, we got simple and compound leaves. So the first leaf you take off, this is obviously a compound leaf. This is one leaf, and you can see all these little leaflets that come off of it. These individual pieces are called leaflets. So it's pinnate because you can see the branching comes from different points along the petiole. And the leaflets are kind of lancet shaped is what it would be called. So they're kind of ovaled with this pointed tip on the end. So a couple more things that we look at in compound leaves that help us identify the species would be the number of leaflets. So this tree would have between 7 and 9 leaflets. So this one here has 9, if we count them out. And then the other thing you look at for compound leaves is this terminal leaflet. So some species would have 2 leaflets at the end instead of the 1 that we see here. So that's another distinguishing feature. Do we want to take a guess at what this species is before I get too ahead of myself and spoil it? It is an ash tree. Yeah. Do you want to take a guess at this type, or I guess the color would be a good clue? No? This is a green ash. Yeah, I tricked you with the last one. Saying that it's not. But yeah, this is a green ash, and the other common ashes in the area would be white or black. Black is definitely a lot less common than the green and the white ash. And of course, the green and the white ash are the most similar looking too, so just to make things that much more complicated. White ash also has 7 to 9 leaflets. Some of the minor details that you would notice different is the green ash, if you look at an individual leaflet, the green ash has the margins all the way down to the bottom of the leaflet, whereas the white ash will only have this pattern on the side about halfway down or 3/4 of the way down. And then another thing I like to use for the green ash to identify it is actually the figure of the tree. So if you look over by where Savannah's standing, the branches kind of droop down and then shoot back up right at the very end. And that is very characteristic of green ash, especially just the branches just above here. You can see how droopy they are, and then they all kind of swoop up at the end. Kind of similar to the way the leaf is itself here. And then one more feature before I bore you to death about the green ash is the white ash is going to have a lot more prominent diamond-shaped bark. So you can see this, it kind of has a little bit of a diamond shape on this bark here between these furrows. But on the white ash, this is going to become even more prominent and more regular than what we're seeing here. I'm not sure if you guys have noticed, but there's also this green dot on this ash tree, which is actually an indicator right now of it being an ash. There's a disease called emerald ash borer that's a big issue now in Ontario, and this green dot along with this tag means that this tree has been treated for emerald ash borer. So it's kind of a good clue to identify these trees right now. Okay, so we got another simple leaf. However, instead of the palmate formation that we had last time, we have the pinnate formation. So I'll hold it up. We can see the prominent veining along the back, kind of goes along the lobes here. And then there is, again, that minor veining on top of it. We see here that the lobes are actually fairly thin, and then the parts between the lobes are called the sinus. And these sinuses are very, very deep on this tree, making the middle bulk of the leaf very narrow. Also, compared to other species in this genus, these leaves are fairly small. So that's another indication that this is kind of a water-tolerant species. It grows a little bit slower. It has less energy to put towards resources such as leaves, so these leaves develop smaller. And then the other characteristic is the actual ends of the lobes. It's that they're pointed, right? So they're nice and pointed, where others in the species could be rounded. It's a pin oak. Like I said, it's a water tolerant species, which makes sense for the location that we're planted. We're right close to the water. They have, like I said, the smaller leaves compared to something like a red oak. The red oak would have a similar kind of formation. They would have an extra pair of lobes, and then this middle section would also be a lot more filled out. With oak trees, another characteristic that you could look at are the cones. They are fairly undeveloped right now. They're really, really small. But again, these are going to stay relatively small in comparison to other oaks. They're going to grow, the cones for the pin oak are going to grow nice and flat with a cone that's wider than it is long. And then again, like I said, for other oak species, these lobes could also be rounded. And that's part of the distinguishing features as well. So, with these trees, first warning, be careful reaching into them. They do have thorns. So, yeah, I guess I'll start with the thorns. If we look right at the base of the leaf where it attaches, there are two little thorns that grow out from the base of the leaf. You could look at them over there, but just, again, be careful reaching in. There's a little one there, and then there would be a little one immediately on the other side here. Like I said, a compound leaf, and it's pinnate again. It has a lot more leaflets than what we saw on the green ash, and it also has a lot smaller leaves with no margins on it. They're round, completely rounded. This one, not a good example. The terminal leaflet has fallen off. There should be a terminal leaflet on this one, but you could see the little petiole where the leaflet was attached. If you look at other ones, they will have that little one on the end as well. And that's the main distinguishing feature between this locust and that locust over there. This is actually a black locust. They grow nice bright flowers in the spring, and they produce kind of like bean-like fruit pods or seed pods. But yeah, we can go over to the other locust. So this is a black locust. We go over to the other locust, which is the honey locust, and we can kind of compare the leaves a little bit. Yeah, this one has a lot smaller leaflets. And like I said, this one is lacking the terminal leaflet. There is no terminal leaflet on these. The other interesting thing about the honey locust is kind of the branching pattern of it. If you look at it, it's very crooked and back and forth, especially along these smaller branches. You can see it kind of turning at every junction. These honey locusts are commonly planted in cities because they're very resilient to a lot of the stresses that you would see in a city. They can survive drought and flooding. They're good with different metals, heavy metals and salts that they see in urban environments. So a lot of the time you'll see these trees planted in the planter boxes along the streets of the city and kind of in the margins of the boulevards and stuff. So here's our next tree. Yeah, so it is a maple tree. This is the red maple, and I'm not sure if you noticed, but I picked a big red maple leaf off the tree, whereas this one seems to be pretty average size in comparison to the other maple leaves. And this is completely opposite from the red maple, and it has an extra lobe. So it has the 5 normal main lobes and then this extra little mini 7th lobe on top of it. And this is actually a Norway maple. So Norway maples are not native, and they're actually becoming kind of an issue being planted in urban environments. The reason for that is actually the size of the leaves. They actually are so big that they provide so much shade underneath the canopy that nothing can grow underneath. You only get all these like weed-like kind of growths. You never get like real good secondary growth of woody trees and things like that underneath. If you look at this tree, actually, you can see these spots that are forming on the tree, and that's actually a bacterial infection as well. It's called the tar spots, and you see them only on the Norway maples. I guess you see them sometimes on other maples. It's just less common. So like I said before, most of the trees aren't named for their leaves. However, this one is. If you look at the top of the leaves, they're like light, nice and dark green. And then when you look at the bottom, it's a lot paler and lighter on the underside. It is a silver maple, yeah. So that's exactly what it is. If you look from the bottom, it has that very silvery color. And then if you look from the top, they have the bright green. So if we look at the leaves in comparison to the Norway maple, they are a lot smaller, right? So they allow that sunlight to get through and allow for that secondary growth to come up. That characteristic trait comes with these very, very deep sinuses. And then also the lobes are very thin and delicate as well. Oh yeah, one thing I forgot to mention about maples that really helps identify them are the keys. Silver and red maple, they have keys kind of go parallel to each other. So I normally like to do this in the middle of the afternoon because then we really get the heat from the sun beating down on us. And as we approach this beautiful canopied area, you'll start to feel the cool air coming in. A forest system like this can reduce the air temperature by up to 11 degrees. So at the beginning of the walk, I said there was kind of 4 main categories of leaves, and I definitely lied, and this is one of the exceptions. This is a really interesting leaf. It develops kind of funny. The terminal leaflet has these 2 extra lobes on the side, and then if we look at the side leaflets, the inside margin is a lot less prominent than the outside margin. This is actually a type of maple tree. This is a Manitoba maple, and they were initially planted for decorative reasons and ornamental reasons. They grow nice and fast, they're kind of shrubby, they have a nice leaf structure, and that's kind of exactly what the issue with them is. They grow way too fast, and they're actually really frail and susceptible to wind damage. This is an elm, and the characteristic trait of the elm is this asymmetrical base. And in other species, this is even more prominent. And then finally, another distinguishing feature is the texture of the leaf. These ones are really rough. This one specifically is Scotch elm. And we could tell this because of these weird little, almost horn-like structures at the top here. Yeah, so this is another compound tree. The easiest thing to do is to just take a leaf and give it a smell. The genus name for black walnuts is junglans. And that is actually a common chemical that the black walnuts produce in their root system. Similar to the Norway maple, it makes it really hard for things to grow underneath it, giving itself the best opportunity to thrive. This is the last tree of the tour. A simple leaf. I tend to not even use the leaves to distinguish this tree apart. I go right to the bark. Really prominent bark pattern that these furrows are actually stick out quite a ways. And when the tree grows up, these don't develop all that much, and they become kind of splotchy, and they almost look like the tree has a bunch of warts on it. They do grow little black berries, or like darkish colored berries that look black, and it's in the name, hackberry. That's what this is, a hackberry. Alright, that's everything. Thanks for joining us on the Long Branch Deciduous Tree Identification Walk.